Hey everybody. Yeah, we're here today to talk about quite a bit of new software that we have out in the world. The Zora project being one of them. It's a project that makes use of Mega Geometry, real-time path tracing, DLSS 4, all the latest bells and whistles. One mega project, if you will. We're going to talk about the latest NVIDIA RTX 55 and DLSS 4 model improvements that are part of that. Right now, at the time of this recording, we have the latest DLSS 4 models, Model E for ray reconstruction, Model, was it J or K? I think it's Model K for super resolution.
For Kelsey.
Thank you. And yeah, and so that's going through QA right now for NVIDIA RTX. And if all goes well, this episode will play on the 7th of May, and we'll have the latest NVIDIA RTX 55 out the day before on the 6th. We're going to have a special guest on today, Ike Nnoli. He is the Senior Product Marketing Manager at NVIDIA. He's going to talk to us about Zora and his work on that project. You know, it's a very large team that helps to make it, but he's, you know, one person of many who contribute to that. And we're going to get his perspective on what it took to make Zora. You know, that project is very big and complex, and so there's a lot to talk about there. Okay, so first things first, let's talk about the Zora project, how to get it, how to install it. So Zora is comprised of essentially two large bits. There's the Mega Geometry branch that you need to get in order to run it. And then there's the project itself. So if you want to check out Zora for yourself, you need to get both parts. I'll step through where to get them, how to install that. This is where you go to get the latest NVIDIA RTX code. And if you scroll down, I'll put that link up here for everybody there, make it more obvious. But if you scroll down towards the bottom, you'll find, you know, right here is all of our NVIDIA RTX branches, the Caustics branch, and you can see here's 5.5 available for download. But if you go over here to this tab, there's the experimental branch, and this is based on NVIDIA RTX 5.4, but it has the addition of Mega Geometry. That's our technology that allows you to take nano geometry and basically path trace it, ray trace it, and path trace it at its full resolution. If you go back to the RTX branch, there's a learn how to access NVIDIA RTX, and we give you step-by-step instructions here on how to link your GitHub or your Unreal account to GitHub in order to test the code.
Yep.
So yeah, if you click through on that, this will tell you everything you need to do in order to get access to the code. The code's free.
Yeah.
So there's just some steps there, and it's fairly straightforward. But once you do that, then you can access the experimental branch. And just to be really clear, we call this the experimental branch only because we're including Mega Geometry. It's preview code at this point. This is not final shipping quality. We don't have like all the UI elements worked out yet. We don't have all the performance worked out yet. The memory isn't, you know, where it could be theoretically. But if you want to get used to Mega Geometry, learn more about it, this is the place to go and download this code. Now, as long as we're here on this page, I'll show you just real quickly. If you're not used to building code, it's actually fairly straightforward. You can just go right here on the page to where it says code and click this. Now you'll notice that there's two ways to get it. In my case, open with GitHub Desktop because I have GitHub Desktop installed, or I can just download the zip, basically just download it directly. I encourage everybody to use GitHub Desktop. It's a good way to get software, manage it, get updates quickly. This way you don't have to re-download every time that there's a minor tweak or a bug fix or something like that. This is the location to get Zora, the project. And if you go to this link here, the RTX Kit link, right at the top, there's a download Zora sample. And that gives you a direct link to the zip file for the project.
Showing here on Richard's screen, we have the different branches. So just like Richard was saying, you don't have to be like stuck, I guess, with one branch. You can have multiple code repositories. One thing
Yes.
though is with any Unreal Engine, with code source, right? And you're going to build from source, you want to make sure that it's not nestled in a bunch of folders. Otherwise, you might have some build errors. So the best thing that you can possibly do is keep
Yeah.
it at the root of your drive. So for example, Richard has a new
Yes.
volume D drive and then a dev folder. That's fine. You can keep your code sources there and build from there. You're not going to have any issues. It's just the longer, like let's say if it was D dev
Well,
NVRTX 5 dot something, you might hit long file path issues, but this is
yeah, yeah.
perfectly fine.
Yeah,
Yeah,
Windows, even Windows 11, the latest version, whatever, it still has like I think it's the 256 character
exactly. Yep.
limit.
Yep.
So just be mindful of that. Yeah, wherever you install it, don't nestle it like she says in whatever a bunch of subfolders someplace. Yeah, like
I
a
used to
dev
keep this
folder.
stuff on my desktop.
Yeah, see that don't do that. Yeah, you that's a problem. Or
That was a
yeah,
long
if you
time
keep it in your
ago.
downloads folder, it's a
Yeah.
huge character mess, right?
Yeah. Don't be like
Um,
me.
yeah. So put it someplace short and obvious, like a dev folder, C drive, D drive, whatever you
Yeah.
have. Here's the Zora code, yeah, I've just unzipped it to this location, and I've already built code, so I'll step you through everything that you would want to do. But I've unzipped the Zora project, or sorry, the Zora code, the experimental branch, and put it here. When you have the code downloaded and unzipped, you also want to make sure that you have Visual Studio installed. It's fairly straightforward. You just get the free version, the community version it's called,
Yep.
and then install the correct modules along with it. And once you do that, you'll then, with the code unzipped, you'll want to first run the setup bat file, and then after that, run generate project files. And if you've done everything correctly, if you have Visual Studio already present, and you've stepped through these, and everything works like it should, it'll generate a project file down here, ue5.sln. Now, similar kind of thing for Zora itself. I've unzipped the Zora project files to, in this case, a different drive. It doesn't matter. You can put the project wherever you want that's convenient for you. And just have it ready to go, and this will be fairly straightforward later. When you build the code, if you've got Visual Studio installed, all you have to do is just double click this UE5 SLN. It's associated with Visual Studio, and we'll launch into the code project.
Now, if you look at the bottom left corner of Richard's screen of the VS22, before you see how it says ready there, but then to the left you see like a little I don't know, chat box looking message box thing, and it looks like it's animated as if there's stuff running there. Richard, if you could put your mouse over to the left. Yep, click on that. So you're going to see all these background tasks. The best thing to do, you don't have to, but it's really good to do this because it helps the whole solution. That's what SLN stands for, is solution. It helps your build by allowing everything to just completely open up. And once you no longer see anything running in that little chat box, that means everything, all the background tasks, the project was successfully able to find all of the required files within the solution or within the project. So once that's done,
that's really good to know. I was never clear on that. I'm not a code building expert, so
no, it just it helps
I assumed I should probably let that finish, but I didn't know that 100% for sure.
No, it's all good. No, and see, that's another thing too. Did it ever stop you? No, it didn't. But it's
No.
good just to let this happen, just in case you may, some projects, some code repositories, some custom ones that aren't the ones that we're, releasing ourselves may need certain dependencies that aren't found, but it just takes a little bit of time to see those files come up through the solution. That's all.
If you get any launch errors, if it throws up any kind of dialogue, typically in this area where it says you need to install such and such modules, just install them, restart, or if it asks you to, just so you don't have any kind of errors or missing parts, because it needs various SDKs and redistributables in order to work. The next thing you'll want to do is just make sure that the solution configuration is set right. You do that from here. It may not default to development editor. So I would recommend you set it to that, especially if you're going to be working with the Unreal Ed and you want to make sure you can load the editor and the full, code. Set it to development editor, in your platform, probably Win64, and then you're set to go. And then all you have to do is you should have a Solution Explorer on the right side over here. If you don't, just use your window tab to get the Solution Explorer brought up. But from the Solution Explorer, go over here. You can go to Engine or UE5. I don't know if it really matters too much. And you can right click and say build, and that'll build your code. If you got everything installed right, and you should at this point, then that's all you have to do. And the amount of time it takes to build the code depends entirely on your machine, how fast your hard drive is, how fast your CPU is. But if you have a fairly performant machine, you can build code. It might take half an hour to an hour for a modern machine, longer for older hardware. But you might expect something like that. So now that I've got my code built, I'm going to go back over here to where I've installed Zora, and I'm going to right-click my Zora project. Yours should look a little, when you first install it, it should look a little simpler than this. You won't have a Zora SLN, for example. That won't be created yet. You won't have some of these like cached folders and so on. You'll see it, but you'll see a Zora project. What I would recommend you do, now that I got the code built, is I right-click this, show more options, and I want to switch my Unreal Engine version. And I'll want to pick the right code for it. You can see I've got multiple Unreal branches installed, but I'll want to pick the Zora branch and then click OK. And when I do that, it will associate the project to that newly built code, and it should generate various cached files like project source, just bits like this, and a Zora SLN file. This is a code-based project, which means after you build code to run it, you also need to build the code for the project, and it's doing that because it has custom plugins, things like that. So same thing as before. I'll double-click the Zora SLN, get back into Visual Studio. And now you'll notice that while there's an Engine UE5 reference up here, but there's also a Games Zora reference in the sidebar. So I can just click Zora, just like before. Oh yeah, and here it's giving me a status check on things I might be missing. Just step through this. I know I've already got everything installed and everything worked, but if it gives you any dialogue like this, just make sure you have the correct packages installed, and it should all be fairly automatic from here.
Not everyone, just to make a note here, not everyone who
Yeah.
downloads Visual Studio 22 may have this. Most people will, just because if you do follow the instructions based on the repository connection between your GitHub account and the Epic Games account, they give you all of the information on the exact modules to download. But over the course of the years, you may be outdated. So another place to see it is over to the right in the Solution Explorer. This solution contains packages with vulnerabilities. Manage NuGet packages. You might also see other things saying, this project requires certain modules that aren't installed. Do you want to install them now? And you can also install them there. So it depends on what you installed or not. But exactly what Richard said, just walk through it and make sure you have everything downloaded. The solution here will tell you if your IDE is prepared.
I built my code. I built my project. Everything should be good to go. Moment of truth. And then I can double click it, and it should load up the correct code. And we're off to the races.
Yay, there we go.
Yeah.
That's exciting. Yeah, and I also think there's step-by-step documentation as well in the NVRTX branch to show you exactly the same exact process that Richard just showed you. So, getting the source code for both the Zora project and the NVRTX, running the setup file, running the generate project files, all of those things. It's all written out in documentation too, so you can follow that too. Awesome. There she is in all her glory. Oh man, all that detail.
Yeah. So it loads up right into the Reister test level.
So you know who would really love to talk about Zora?
Yeah, who?
Ike Nnoli, our senior
I was just thinking about that.
marketing man.
Yeah, we have a guy at NVIDIA. He's the man.
He is the man.
Who's he's the senior product marketing manager at NVIDIA, and we're gonna bring him on right now to talk about Zora, his experience, working with the team who developed it and helping with that and everything about it. So let's bring Ike on. So welcome. Thank you for being here. He's our special guest this week.
Thanks, Richard. Thanks, Kelsey, for inviting me. Super excited.
So I know Zora is a large team effort. A lot of people worked on it. I mean, it's not an exaggeration to say hundreds of people at different levels have been involved in this project to some extent. There's a core team and then lots of additional help because there's a lot of technology that goes into this. Your role on the project, were you then a product manager for it? Were you one of many? How does that work exactly?
Yes, absolutely. So I had like a dual hybrid role, product manager as well as product marketing. And what that means is that, like you said, there was a lot of people involved in the Zora project. We had our Lightspeed Studios team that was, building a lot of our assets. We had research and engineering, kind of integrating the technology. We had also, you guys were involved in this project from a Unreal Engine 5 perspective where
the tiniest. I had the tiniest of tiny. I think Kelsey was more involved than me. Maybe, I'm not sure.
About the same.
Yeah, I had the tiniest of roles.
But Zora built an Unreal Engine 5, so there was definitely involvement from the Unreal Engine 5 experts here. And then from the point of this project being built, and then how do we package it? What's the focus area? What does it look like when it runs on our GPUs? How do we talk to press about it? That's where a lot of my involvement came in. So a lot of various requirements in terms of, where does this technology need to run? What GPUs is it compatible? What's the performance? How do we present this to developers? I've had a lot more involvement there, and that's kind of like the product and the marketing side. And then from there, you're messaging this product to developers and to press. And so a lot of that work that kind of falls onto me.
All right. Okay, so that gets directly. Yeah, that is a lot. Yeah. But okay, so that gets directly to my next question then, which is, if you're talking to a developer for the first time about Zora, trying to explain what it is, and they have no idea what this project is all about, what would you say to them?
Yeah, so Zora is our Blackwell showcase technology demo. Blackwell is one of the big pillars of Blackwell. It's a neural rendering GPU. And we wanted to demonstrate what Blackwell is capable of with a demonstration, and that's Zora. So Zora features some of our cutting edge neural rendering technologies, as well as some of our cutting edge path tracing technologies. And so Zora is a culmination of, 30 years of rendering research and work. And it is a kind of a demonstration of what the future of gaming will look like.
Yeah. The big ticket item here, or items, being DLSS 4, Mega Geometry, Reister path tracing. I'll put up a reminder link. This is where somebody could go get it, the Zora project, and the custom code to run it. So they can check out Mega Geometry and path tracing there and see what that's all about. We don't want to get into pre-announcing anything or saying a date certain on a certain update or whatever. Can you say, is it going to be updated in the future? Are we going to see more from it at any point? I think a lot of people are just curious about that. So what would you say about that sort of question?
So I think, recently we released gems, which are like separate, smaller pieces of Zora as source code that developers and enthusiasts can compile on their own to kind of play with. And these gens, specialize in specific technologies such as Mega Geometry. We're going to continue. There's a couple of gens that we still are planning to release in the near future, such as a Restore DI scene in a throne room that people can play with. And so we'll have a couple more gens coming out, but outside of that, we can't speak to more about the future of Zora as of right now. Just some cool key, factoids of this scene. Like I mentioned before, it's built on Unreal Engine 5. It's using Nanite, right? It's using Nanite meshes
extensively. Yeah.
Extensively. And pretty much per scene, you're seeing hundreds of millions, up to 1 billion triangles per scene. So it's very dense. It's fully path traced, so that secondary as well as primary rays are fully path traced.
Right. People can see a good example of that here. Looking at the path traced reflections, I mean, that's a mirror. Sort of almost infinite recursive bounces going on.
Yeah, absolutely. So like actually getting real-time performance, I don't think this has been done anywhere else, getting above 60 frames per second with DLSS 4. And so a couple other cool things, our team has put, over 30,000 materials in Zora. There's over 2,000 particle lights. There's over 1,500 textures. We threw a lot at Zora to really showcase kind of our technology in its best light. And so, like we mentioned before, DLSS 4 is in here. So that's super resolution, ray reconstruction, as well as multi-frame generation to get real-time performance. And two technologies that we had announced when we put out this demo, Restore PT as well as Mega Geometry is here.
We've released so far little vignettes, but not, there was an early CES video, and some developers have seen it. So we've shown this in person, but we haven't put out the big map yet. Is that a yet thing, or how would you characterize that?
Yeah, so I think it was a internal decision where, if we put out these smaller gens that are focused on key technologies, it's just easier for developers to get access to and play with.
Right.
File size is a consideration. The large scene is very heavy, and then there's just a performance and a quality assurance level that we want to make sure that we hit with these scenes. And putting out these smaller scenes is definitely much easier for our teams to do and at speed of light effectively.
Right. So it would make it would make a big project even bigger.
Exactly. Exactly.
Okay. I guess I'm curious to know, did anything surprise you about the production of Zora? I mean, we were inventing technology as we went along, and sometimes that it produces maybe a happy accident or takes you in a different direction. I'm just wondering if anything like that came up. So that was sort of maybe out of left field or unanticipated.
Yeah, I think probably the biggest surprise, well, it shouldn't be a surprise, but building foundational brand new technology and using cutting edge engine tools like Unreal Engine and the different versioning, there's always a lot of new problems that show up that you didn't anticipate. And some people might be asking, like, why do you have multiple scenes and multiple gens, and why not all the technology in one scene? I think it comes down to the fact that Unreal Engine 5.4 is very different than 5.5, right? And there's different considerations in how the technology that we're inventing plays with each of these versions. Introduces whole new problems. And so I think one of the things that surprised me was just how much consideration had to go into all the individual technologies and what is the impact on different versions of the engine. Impact on performance, impact on just the visuals and some of the common artifacts that you may see, and all those other considerations.
Yeah, performance is an interesting topic here, right? Because I mean, we've attempted to be clear about this. Mega Geometry is put out in Unreal at this point as a sort of preview code, right? It's pre-beta. It's meant to be used by developers who are curious about the technology, who want to start to get used to it. But we don't have like final performance metrics yet for Mega Geometry in Unreal specifically. That'll come later. But for now, it's really just a preview. And we're doing amazing things with it. Like you said, millions, if not billions of triangles being rendered
I mean,
But
look at the ornate. Look at all the ornate
yeah, I
details.
know
Like,
you
wow.
can zoom in on any part of this,
Oh,
and
wow. That's
just
nuts.
an unreasonable, crazy amount of
Yeah.
detail. I
Fun.
mean, yeah.
Yeah. And Mega Geometry allows you to finally get rid of proxy meshes. It's the actual detail. You can, render triangles the size of pixels now, thanks to Mega Geometry. So
Yeah, exactly. Yeah, I was noticing here, like you just like this is all mega geometry detail, and if I zoom in on it, the amount of detail here is incredible. But the big advantage to nanite, in the mega geometry context is you don't, you don't see any LOD pop. Normally,
Yeah.
you would this would be crazy with LOD pop, and we're not getting any. It's just a great continuous, smooth mesh look to it, no matter what distance you are to the surface.
yeah, and in RTX Mega Geometry, it was intended to help developers who are using cluster-based geometry systems like Nanite to build their
Right.
BVH extremely quickly, right? And the quicker you build your BVH, the quicker you can start getting the path tracing. And so, one of the challenges we saw pretty early on was if I was to use Nanite and I had billions of triangles, if I path traced every single one of those triangles with high detail, my frame rate would be 0.
Right.
So how do we make that? How do we build game ready performance with billions of triangles at high fidelity and path tracing? And that's kind of how Mega Geometry was born out.
What sort of takeaway would you want a developer to have from this project? Like, I'm pulling this down, I'm looking at it, I can see the benefits of path tracing, DLSS 4 is clear, ray reconstruction is doing a lot of work here, and Mega Geometry is creating these incredible details. But, as a developer, I may want to take some of these technologies into my own project. What particular guidance would you give for that to a developer? Or, should a developer just look at this project and let it speak for itself?
Absolutely. So yeah, I think the goal for this project is to show developers what's possible with the technology that's available today. And I would encourage all developers to, all this technology that we're showing here today is available either in SDK form or through Unreal Engine 5 and experimental branches or NVRTX. So like Richard had mentioned, RTX Mega Geometry, you can experiment with that now in an experimental branch of NVRTX.
Yeah.
Restore PT is available in UE5 right now as well, and DLSS 4 is available as a plugin. And so I absolutely encourage developers to play with this technology, and it's always good to kind of show what's possible with this technology, so developers can kind of start getting an idea of like, oh, maybe if I do more intricate detail, now this intricate detail can look amazing at every distance from the camera. And now that I have a vision of what this looks like, it can give them ideas effectively.
Another thing you're involved with at NVIDIA is RTX Kit. Is that correct?
Yes.
Yeah. I mean, probably intimately so. Extensively so, I would imagine. RTX Kit's very cool. And we kind of gave a preview of it in the context of Zora at GTC, where we talked about, or, we showed things that aren't in Unreal yet, or not in a production capacity, but things that are coming up, like neural materials and neural texture compression, path traced hair. Those are all things that we previewed a couple of months ago, but we don't yet have them, like I said, in a production shipping capacity in Unreal. What are your thoughts about that? Like, I mean, Kelsey and I, we're very curious about this ourselves because we're very focused on the Unreal side. But we're looking ahead to these next step technologies, these more advanced like neural systems. We get into that a little bit here with DLSS 4, ray reconstruction, that's neural rendering. But there are further steps coming up that are going to take this even further. So I'm just wondering what you think about all that. And we don't have anything to announce yet as far as how it relates to Unreal specifically, but there's a lot of progress happening with those technologies.
Yeah. So RTX Kit is our suite of neural rendering technologies. Not everything in that kit is neural rendering, like AI based, But the goal is, in some future, everything will be AI based. And like you mentioned, Richard, neural materials and neural texture compression were shown off at CES. And we did show off like a demo scene, but right now it's definitely heavily in research because this technology is definitely a little bit farther down the line. But technology itself, super exciting. I think this is going to be the future of how graphics rendering will be done. At a high level, we have neural texture compression SDK available for developers to play with. And we have neural shaders SDK available for developers to play with. And the core principle here is we can now train and deploy tiny neural networks directly within shaders. And what that means is, stuff like DLSS was, a neural network that's on the post-processing side where we're, generating pixels, generating frames. Now imagine that in the core pipeline, you can use AI to generate lighting, generate materials, generate geometry, generate physics, generate water physics, generate hair, there's the only limit to what this capability is essentially the developer's imagination. And the neural shaders SDK here, to unlock kind of that ability for developers to use AI to either, compress data really well, neural texture compression, or approximate different things in the game world at real-time performance.
Wow.
Yeah, I think to say that developers are interested in neural texture compression would probably be an understatement.
Absolutely.
Because I mean that's a big driver of memory costs is textures. And if you can get it's all hypothetical until we make it fully production ready. But if you can get 3 to 4 gigabytes of texture memory down to whatever, 800 megabytes, half a gigabyte, and I know we've been looking at compression ratios in that ballpark, right? It's like in the 6 to 8 times ratio. Real-time compression is possible using artificial intelligence.
Yeah, same quality.
Correct me if I'm wrong with any of that, please.
No, yeah, you're correct. Same quality that you would get from traditional block compression that a lot of the game developers use today.
Right.
But you'll get up to 8x less memory footprint, depending on where you want to load your textures. So
that's wild.
You can reduce your memory footprint in your storage. So if your game is 200 gigs, it could be, say, hypothetical situation. Say you have a game that's 200 gigs and half of the footprint is textures. Right?
Yeah.
So if you can reduce it up to 8x, you can drop a 200 gig game to 120 gigs, for instance. Or if VRAM is your issue, and if you can also reduce your VRAM consumption depending on where and when you want to load your textures. So yeah, it's definitely something that's super exciting.
Wow, no more oversubscription of texture pool. What? That is amazing.
Absolutely.
that warning all of us have inevitably seen multiple times at the top left corner of your screen. Overcommitment.
It does open up new capabilities too. Theoretically, I mean, somebody could create a project with all 8K, 16K textures, whatever the limit, whatever would previously break memory limits is now possible, in a way that it wasn't possible before.
Yeah. Absolutely. And that's kind of, you can use it in a way that saves memory, or you can just do more now with the same things that you're using before. And that's kind of the thing around neural materials, because neural materials, what it does is really it compresses shader code. And, the more complicated and the longer your shader code is. So imagine a film quality material that you'd usually, unable to run at game ready performance. If you're able to compress it, much faster, and you'll have essentially an AI model that can actually approximate what this material will look like in real time. And so that approximation will end up, looking like a film-like quality material, but you'll be at 60 FPS instead of 5 FPS or whatever it would take to fill a room full of, film-like quality materials.
And just to be clear too, there is a difference between neural materials and neural shaders, right? Like those are two separate SDKs. Do they work together, or are they completely orthogonal?
Yeah, so you can think of it like this way. You can think of Neural Shaders SDK is the foundation, and Neural
Okay.
Materials and Neural Texture Compression are two applications of that SDK. Yeah.
Ah,
So you can
okay.
so essentially we built those, well, Neural Materials as an SDK does not exist, but like Neural
Right.
Materials, the technology, as well as Neural Texture Compression was built from the Neural Shaders SDK. And those are
Ah,
just two examples. And
Yeah.
once more and more developers play with neural shaders and a lot of this stuff starts getting into engine platforms and starts getting a wider distribution, you're going to probably see some crazy things coming out with people building stuff for lighting and physics and what, who knows.
Who knows?
so that, yeah, so
No,
like that amount of detail that you would get from all of the textures that you could create at such high resolution being compressed so that you can actually run it at real time at runtime, and then also with materials being applied, you know, uh, on top of like high-end mega geometry meshes. Like, whoa, this is gonna be nuts. I'm excited for that. That's gonna be cool. That's crazy.
Absolutely.
yeah, it starts to enable more and more cinematic quality graphics, basically,
Let's
at runtime.
go.
Yeah,
Yes.
because there's certain materials, and for our demo we chose a material that was very hard to render traditionally. Multi-layered materials that have
Yes.
like silk that has multiple different hues and colors,
Oh,
or
yeah.
like certain car paint jobs are very hard to render in a game.
Yep.
Neural Materials is
Right.
very good for rendering multi-layered materials as well, because
Yeah.
you
Yeah.
can stuff more information in the shader code.
I do want to ask you an out of left field question, and that is, just sort of little known fact. We have in-house artists at NVIDIA, probably more than people realize. I mean, it's an engineering company, but we do have a lot of artists. Like, they made Zora, and the quality of the work shows. It's a lot of industry pros, people with game industry backgrounds. This is a question we do get from time to time from people. They, if they wanted to come work for NVIDIA, come work on one of those art teams, what would your advice be to them to get noticed?
Yeah, absolutely. A lot, like you mentioned, there's a lot of artists here at NVIDIA that have had prior industry experience. They've come from other studios where they were working in our capacity, or they came from other industries that are
Yeah,
adjacent to this, like
sometimes
media and
VFX,
entertainment.
sometimes
Yeah, VFX.
wherever. Right? Yeah,
Yeah,
I mean,
so
I spent time in the game industry, so that happened a lot there too. You get people coming in from Hollywood or whatever, coming to
yeah,
games. Yeah, but
exactly.
not
So I
everybody
think,
makes the crosses over from like games to tech. So
Yeah.
that's not everybody is sure about that or comfortable with it. I made that crossover, but not everybody does. So yeah, I'm just curious if what your advice would be about that.
yeah, I think my biggest piece is that, like, get as much experience anywhere you can. The gaming industry obviously helps, but gaming industry is not required, right? People come from various industries. I think it's really good to kind of obviously you can be self-taught when it comes to a lot of this stuff. Unreal Engine 5 is publicly available for a lot of people to play with, and
That's how I started.
yeah, and it's
Way back in the day. Yes.
and it's an engine that
UDK.
is and it is an engine
Yeah.
that is used, and it is an engine that is very popular across industries: automotive, media and entertainment, gaming, every industry. So there is no limit to kind of getting your feet wet in that space. And I think start building up a portfolio. I think build up a portfolio of your work, what you've done in the past, and I think from there you'll kind of have a strong foundation. Artistry and just the technical artists are definitely an in-demand thing, especially as the digitization of everything is still continuing, from digital twins to gaming and rendering. So I think it's a very hot in demand field still, and will be in the
Yes.
future.
Yeah, there's for sure there's a lot of people with game industry backgrounds who don't necessarily have cinematic quality art backgrounds, right? Like don't necessarily have those skill sets. It's a good opportunity for people with different skills and backgrounds, like coming from VFX or Hollywood or whatever, to get their feet wet in Unreal and sort of be amazed that you can do, if not cinematic quality work, you can get very, very close to it. and do it in real time. I don't know if we're quite at Infinity War Thanos level graphics yet, but it seems like we're getting closer and closer by the minute.
Sure does feel that way, doesn't it? Yeah.
And that was only 2018, so that was just 7 years ago. Let's look at the greenhouse level in Project Zora. What would you say about the greenhouse test environment? Clearly, we're stress testing foliage, real-time shadows. Do you have any commentary on this?
Yeah, I personally really like this test environment because it shows Mega Geometry in a great light. There's a lot of vegetation. Vegetation is very hard to do extremely well. Like individual leaves and blades of grass are shown off very well. It's a very complicated lighting scene where Mega Geometry actually excels much in, because there's no proxy meshes. Like the shadows and the shadows you see on the ground are highly detailed. It's the exact shadows of all the infrastructure that you see in the scene. And so this scene with all the very thin supports in this greenhouse treehouse level kind of is a good representation of like the benefits of Mega Geometry when it comes to shadow detail and quality.
Yeah, it's quite incredible. Awesome. Okay, thank you for your time. Really appreciate it.
Thank you, Ike. Bye-bye.
We'll see you. Bye.
Let's get into the CVARs just a little bit. If I go into my config folder for Zora and I look at default engine.ini, we try to make this very well commented. So you can, here we've got CVARs for Mega Geometry, setting up what the memory buffer should be, various preferences for that. I want to focus though, if you scroll down here to the sample lighting section. I know this looks like a lot. We're gonna hone in on a couple of details. If I look at our sample lighting, so this is all my real-time path tracing settings, and I'll admit, much of this could be looked at as redundant because a lot of the values here are not necessary. You don't need to copy this one-to-one for your project. A lot of these values like sample lighting direct 1 or indirect 1 or quarter res 0. These are default values. So we probably just set these values here because as we're developing the project, we're figuring out what the default should be. But it's really not necessary to, like I said, to copy this one-to-one for your project. What's noteworthy here are just a couple of values. Max history 3, which you could set in your post-process volume. There's a max history length, which defaults to 8. This is the number of history frames to consider when looking at temporal information with real-time path tracing. Like I said, the default is 8. The really cool thing about the latest version of ray reconstruction, which we're using full DLSS 4 here. So we have DLSS super resolution turned on, ray reconstruction turned on. When you're using ray reconstruction, you don't necessarily need a long history length in order to get your scene to look good. With older denoisers, maybe software written denoisers like NRD, you probably needed more temporal information in order to make sure the quality was high. But with ray reconstruction, a lot of the denoising is done in the frame, or maybe not in the frame, but it at a minimum, it doesn't need to consider as much temporal information. And remember, this is the number of frames it's going to consider. So if you wanted to tighten up any, say, like shadow lag related issues, or any sort of like temporal issues, you could shorten this value. We've already set it, like I said, it's been set in the console variables, but for your project, you can just set it right here in the max history length. I would encourage you to try this and just experiment with it. It doesn't cost more or less performance to raise the number up or down, but it's still a valuable number to play with. And you might, I think, so for this one, we set it down to 3. I believe we did something very similar for amusement park. We set it down to a value of 3 or 4.
Yep.
Yeah, I wouldn't recommend going down to 1. The 1's always an option. 0 is not an option. That won't work. But you could, the shortest you can go is 1. you do want some temporal information for general image stability. So I wouldn't, like I said, I wouldn't eliminate it completely. But a value of 2 or 23,
23.
a value of 2 or 3 might be entirely valid, especially when using the latest ray reconstruction.
Yeah.
So yeah, max history of 3. That's a good one. Indirect mode 2. This sets your real-time path tracing. The default value is mode 1, which is Riester GI. That's path tracing for global illumination only. It doesn't solve path tracing for full mirror reflections. So if you want, and by default, when you turn real-time path tracing on, it defaults to indirect mode 1. So that's Riester GI, the simpler mode. Internally, sometimes we refer to this as baby path tracing.
Yeah.
But if you want to do full path tracing, you set it to mode 2. That gives you full reflections, full GI. Yeah, so for CVARs, I just want to call out that you can tweak the history value. There's no performance cost doing it. It's just like, visual quality tweaking, possibly to give you better, more responsive shadows overall. Indirect mode 2 is to make sure your path tracing is turned on. And I would also recommend the simple mode 1 right here. What this does is a little technical, but basically, if you're using full real-time path tracing, you probably want to use the Riester PT simple mode 1 value. By default, it's set to 0, and that means it's doing mode 0. Mode 0 for this is full path tracing, full quality path tracing. Mode 1 mixes Riester GI for the global illumination part, and then Riester PT for the reflection part. It mixes them together. Why would we do that? This is a temporary measure. This is real-time path tracing. Riester PT is brand new in Unreal Engine. It's at this point, it's about 2 months old. And as a quality measure to make sure that the global illumination portion of path tracing is stable, the Riester GI part of Riester GI compared to PT is more stable in motion currently than full path tracing. So in terms of global illumination, Riester GI and Riester PT basically look identical. There's very little quality difference between the two. But if you want to make sure your path trace GI has a lot of stability in motion, I'd set the simple mode to 1. And in the future, this CVAR is going away. This is where the code is at today in NVIDIA RTX 5.4 and 5.5. In the future, we won't be doing this anymore. But in the meantime, this is just a temporary measure until we've achieved that. I hope that all makes sense.
Right. And the in the following updates that we have, the anticipation is, even though this is going to completely go away, we're going to still keep the quality that we're able to achieve with this CVAR enabled, in other words.
Yes. Yeah,
Yeah.
exactly. Yeah, it's this CVAR only exists because Riester PT is in its infancy. Like I said, in Unreal Engine, this code is 2 months old. So it's developing rapidly. We're making, as I said, there will be another update by the time this broadcast happens. There'll be another update for 5.5.
Making
And
amazing
so,
progress.
Yeah, path tracing code is developing rapidly, but this won't exist for much longer.
Yeah.
And you can see some of the other. This is like quarter res mode is not yet ready for prime time. We can just look at it real fast. So here I'm doing
That's
full path
interesting.
tracing.
Yeah.
If you want to experiment with it and see what it's all about, you can type quarter res, indirect quarter res, and by default it's 0. It's off. But if I set it to 1, you'll see that my scene doesn't look any different. Let me put the frame rate on. Right. So I'll go back to off. Right. So here we're doing full resolution path tracing. Right. We're considering almost every pixel. Quarter res, we'll look at every other pixel in the X and Y, right? So we're doing 1/4 of the amount of sampling. I just did it, and you saw the instant frame rate boost it did.
Boost.
Now it looks
Yeah.
great. It looks great in a still frame. It may not look totally great in motion yet. That's a
Yeah.
denoising issue. So we're working on that. If you want to get a preview for what quarter res does to your scene, you see that it's not bad. Actually, let me deselect the post-process volume. You can see it's not bad, but you'll notice a very slight amount of instability in the GI
Yeah.
as I move through it.
With little
That
tiny bits of boiling. Yeah.
just a little bit,
Yeah.
right? That if I go back to full resolution, that go away, right? The GI is much more stable.
Yeah.
Um,
How is it in the reflections? It should be the same, I'm assuming.
well, no, quarter res is probably more brutal on reflections than
Yeah.
GI at the moment. So yeah,
Ah.
here's a full res, I believe, reflection, and then if I do quarter res, again, looks the same in a still, but in motion, you'll notice like
Oh yeah, there you
various
go. Yep.
sinking and disocclusion artifacts and stuff like that. The
Yep.
performance increase is very encouraging.
Yeah.
This is a problem that we can solve with by basically improving the algorithm a little bit, along with improving ray reconstruction. So
And
so
quarter
this is
res is
yeah.
also this quarter res CVAR. It's got to be applied global. This is not something that's
Oh yeah.
available in the post process volume. So it's not like you can pick and choose. It would be nice, right? Because then you can like, well, I don't really care for much of this area here. Like it looks good in motion. I'll just reduce the quarter res to quarter res and go from there. And then pick it another place. You can't do that. So this is globally set.
It's either on or off.
Yeah.
But you can eventually, for example, you'll be able to make it a user preference.
Yeah.
And you could imagine, therefore, like maybe a low resolution path tracing mode versus a high resolution, medium quality versus ultra quality, right? So you'll have that kind of tool in the tool bag to maybe try to make Reister GI a lot more performant on considerably older hardware, or even on non RTX hardware.
Oh yeah, that's a good point. You're right.
Right.
Yep.
So yeah, I mean, like I said, you can see that it's quarter res in its current iteration is pretty good, but it's not ready for prime time yet. We include the code today just so you can fiddle with it, understand it as an option, see what it's doing to your scene. But we have more work to do in this area, and more optimization to do all the way around. I mean, none of these technologies are holding still. Path tracing and ray reconstruction and even mega geometry are constantly improving. It is cool how that looked almost no different though, right? Like,
oh yeah, no, standing still,
if,
it's unbelievable. Yeah.
if you just look at it, in a still frame, and then switch to it, I can't see any difference whatsoever.
No difference. Even on like all the intricate details of the meshes, far away.
Yeah.
It's still able to sample it.
Yep.
And this, just to be clear too, this is also including DLSS ray reconstruction. Like DLSS ray reconstruction is on, so that's also
ray reconstruction is doing a large part of the work here. I mean, I would, if you're doing full real-time path tracing, I would strongly encourage you to also use ray reconstruction. It'll give you probably the best real-time signal, especially with very sparse sampling. Ray reconstruction is a big part of the success for real-time path tracing. They go together. It's your peanut butter and jelly sandwich, right?
Yeah. Yeah.
I want to talk about this other test scene. So this was just an experiment. Wanted to see if we could light a scene just using physical materials, using the latest path tracing code. This looked interesting. This is up on Fab. It's called Nova Space Burgers. I'll load up the project here. I'm going to load this up into NVRTX 5.5, which, with any luck, this latest code is out by the time this broadcast hits. And if it's not out, then we'll talk about that in the QA at the end. But just to make sure, Yep. So this is using the latest 5.5 code, including the latest DLSS 4.
I love emissive materials, like animated emissive materials that actually produce true light.
Yeah.
Like you're just like throwing like a paint bucket of paint all over the scene. Oh my gosh, it's so cool.
Yeah.
I don't know.
No, this gets I don't know what to say about it. I feel like it's one of lifelong ambitions to light a scene entirely with physical materials.
Yeah. Look at all those lights.
Yeah. So this is the scene before I made any changes to it. It's fairly straightforward. You can see that there's a light mass importance volume around it. I think an earlier version of this, or maybe this version, I'm not 100% sure, was light map. Originally, this was light map. And this is using a lot of actor lights, so you can see rect lights positioned all over the place. A lot of point lights. There's a point light in here. Here's a rect light just for a little bit of fill.
Awesome. Yeah.
In total, there's some 60 light actors. All of these. Let me make sure I'm not going to select the translucency. No. Yeah, so you can see light actors placed all over the place. But the cool thing about real-time path tracing is there is the capability to generate light in a more accurate way just from emissive triangles. It does that to an extent right now. It's not, I would caution this to say that it's not going to be like a perfect or complete light solution. We can get more into those details, but I'll just load up so this is the lumen version, basically, with a lot of light actors placed. Let me load up the real-time path tracing version. Same environment, but all of the light actors, except for a handful, are removed. The light
massive reduction of lights. That's amazing.
If I go into the outliner here, you can see that there are 4 point lights, when originally there was like 30 or 40 point lights and maybe, like I said, another 20 rect lights. It was like 60 lights total.
And not all of them were shadow casting, right? Like some of them were just purely for fill, if I remember correctly.
Yeah, that's right. I think it was a mix of some shadow casting, some not. But yeah, here I've got 4 large point lights, just because the current emissive generation, like lighting system with real-time path tracing, isn't mature enough to generate enough like emissive light from such a relatively small shape. You can generate pretty good lighting from this, but not to the point where you have this large light source that generates like this kind of precise direct shadow. We're not there yet. So that's where I would caution you about this. But everything else, all the other light sources have been removed. And let me just get in here a moment.
The fact that this is so dark, like it's just generally like the colors of the inside or the interior of just like the general materials outside of the emissive lit ones, but like the colors or the values rather are so low, like low values, and yet we're still able to keep such stability with the emissive lights, the emissives casting some kind of light, and DLSS reconstruction, and basically zero. There's some instability here and there, but basically zero instability is just mind-boggling. And especially with how crisp you have a lot of the details. Like, great example is right here. You're still able to get a good solid roughness variation with just the emissive light on the wall and DLSS ray reconstruction without removing any of the roughness variation and keeping it all there, on top of the fact that I'm pretty confident that's a decal, isn't it? Like,
oh yeah, we're looking at a lot of decals.
Yeah, that's crazy, like how well it's picking up the different roughness variations of the decals themselves too. Like, I just love that. I love that. It's crazy.
Yeah. You can see it's set up for Lumen, but we give you the ability to add Reester path tracing on top of that. So you do that just by clicking on this option. So if I turn that off, we go back to default hardware ray trace Lumen. And you can see some of the problems if like you tried to light this scene with default Lumen, right, at its default resolution. You know,
Yeah.
it's pretty
boiling.
good, but you can see that there's a lot of boiling and it doesn't have the resolution to pick up certain details. Like you can see, you know, there's a lot of hot boiling there. This simply doesn't have enough surface area to, you know, make this represented well. No fault of Lumen whatsoever. It's not meant to be a completely per pixel system. Reester is meant to have a very high res sampling, and a lot of physical accuracy to it. So there's nothing wrong with this at all. But if you wanted more physical accuracy, more precise sampling, you turn this on, and then you see what that does. Like if you look at this direct lighting and GI contribution.
Oh my
you know,
God.
there's Lumen.
Yeah.
Right. And then there's Reester.
Yeah. And to be clear too, like DLSS ray reconstruction is currently in use. And regardless of the fact that we're enabling RTX, DI, and direct lighting in Lumen or not, it's still DLSS ray reconstruction all in the same. So you're seeing an apples to apples comparison in a sense. In terms of denoising.
Yeah, ray reconstruction is probably improving. It's improving the quality of hardware ray trace Lumen here just a little bit, right? It can denoise hardware RT Lumen, I believe, to an extent. It tries to improve that signal. So yeah, I'm not toggling ray reconstruction on and off, leaving it on. But yeah, you can see the noticeable uplift with you know, quality and you know, overall resolution uplift you get by turning
fine
on
normal detail.
path tracing.
Like it's crazy. The fine normal detail and also the like intensity of like the specular highlights that you see, complete stability, ability to see the light bouncing off of those like very crisp and like glossy or low roughness values of the material. It's like, oh my gosh, chef's kiss. Really, like I love that so much. Like you got to play with that color, man. Let's do this. You know, I'm so excited.
Yeah. I mean, Lumen's not doing too bad up here at all.
No, not at all.
But
what lights? There were lights in here too, right? Like
actual there were
lights. Yeah.
There. So if I turn off, let's just look at it. If I turn off path tracing completely, set it to 0.
Okay.
You can see that there is some direct lighting here, right? There, like I said, those big point lights, and they cover a lot of area, so you can see some direct shadow there. But this is without any GI, without any path tracing. It's just using the direct lighting information. So then if I, which means we're not getting any contribution from, and there's no lighting contribution from emissives like this.
Yeah. Yeah. Wow. Yeah, the surfaces are just insane. In a good way.
Yeah. Something I'll show down here, because this is a lot of fun. All I did here was I just duplicated one of these meshes and you know, moved it around. But you can see there's just a little closet back here, like it's an empty room in the layout of the level. And while it's not completely perfect, you can see that the just using pure emissive, we're able to get quite a bit of direct lighting and you know, indirect bounces and so on.
It is so dark in there.
Full real-time path tracing.
And so stable. Oh my gosh.
Yeah. I'll turn off, so there's hardware lumen.
Yeah. Yeah, the sharp edges of things lose detail as well.
Yeah. Now if I turn this on.
Yeah, there you go. Wow,
So
that's
real-time
amazing.
path tracing, it just has the capability of giving you a lot more precision. Now, but to really caution on this, this is the bleeding edge, right? I love this progression. We're making emissive lighting better. It's not fully resolved yet. Like I said, if you wanted to have a small emissive source with a giant casting radius on it with really precise shadows, you still want to use actor lights for that. And there's in fact 5 actor lights in the level. There's the 4-point lights, and then a skylight, which is providing path trace direct lighting in the level.
Oh, and just because I was just saying this too, if you do have the experimental branch, you can do all of this in the experimental branch as well.
Yes.
So it's not like it's the only difference is the experimental branch has the inclusion of Mega Geo. That was really cool, and the ability to see something, like I said many times before, I'm going to say it again, the ability to see something so stable and vibrant in such a very dark scene is just mind-blowing to me. And it's great to see that we have an even better version of DLSS ray reconstruction out now, or
Yes.
hopefully now.
Yeah,
that
cross his
can handle
fingers.
that.
It should be out the door.
Yeah, so that's really cool. So thank you for
If it's
sharing
not,
that.
as soon as we do the live Q&A part, we'll be issuing apologies to everybody and saying we're sorry.
Yeah, that'll be number one question is DLSS ray reconstruction out. That'd be a very good question to ask.
Yeah. Oh, also worth noting, got to bring it up every time. This is our Discord server. If you want to chat with us after this broadcast, we'll probably be hanging out in there. Come bug us. Well, I've got our support email up. So if you have any questions about anything that we're doing, Zora or NVRTX, real-time path tracing, Mega Geometry, please email this, especially if you're working on something like really exciting. Like, we can help.
Yeah, absolutely.
Well, see everybody in the live Q&A right after, so stick around.